Hello everyone. Today I am going to lecture on origin of soil, grain size, which is particle distribution curve, coefficient of uniformity (Cu) and Cc, and plasticity and structure of soil, which is liquid limit, plastic limit, and plasticity of index, and classification of soil, which is sand, silt, and clay. So let's start. For before starting, I have to give some basic, which are the coarse grain soil are and fine grain soil divided by number of 200 sheep. So at first we have to understand the sheep. Here is the sheep. So sheep is distributed here at first here. So we can say the at first the sheep is distributed here, number of 200 sheep or 0.075 millisheep. The below of 200 sheep is, we can say, pen, and above the 200 sheep we can say the coarse grain. It could be gravel, it could be sand, but coarse grain sand are divided also two types. If number 4 above the number 4 of sheep, which is gravel, and below the number of 4 or 4.75 mm sheep, which is called sand. So this is the basic I have already written here. So coarse grain soil is above 200 sheep. Here is a sheep. Coarse grain soil, you can see the above all the coarse above 200 sheep is coarse grain. It can be gravel and sand. And fine grain soil is below 200 sheet, which is fine grain soil is below 200 sheet. And gravel and sand soil divided into gravel and sand, which is coarse grain soil. Gravel and sand is divided by number 4 sheet. Here is a 4 number sheet. And gravel sand, gravel grain soil, which is above the number of 4 sheep. Here is a 4 sheep. And sand grain situated below the number 4 sheep. Sand grain here. Okay. So silt and clay situated below silt and clay situated below the 200 sheep. 200 sheep. So we can say divided at first to 100 sheep. We can find the coarse grain. It could be sand or gravel. Below the 200 sheep, we can find the fine grain set, which is silt and clay. So the major concern in our geotechnical engineering, silt and clay, which is pen is retaining how much below 200. Pen is retaining 50% particle than fine grain soil, silt and clay. Okay, I have already said that. So at first, now we'll go to the example. Before going the example, we have to memorize some sheep in millimeter. Number 4 millimeter, we have seen here number 4 sheep, which is 4.75 mm, and 40 sheep, which is 0.425 mm, and 200 sheep 0.075 mm. Okay, so let's start the example. The example is given. The material is passing number 4 sheep, which is 76%. So this is the 4 number sheeps and the soil is passing the 76%, and the material passing on the other hand, we have seen the 200 sheep. Here is a 200 sheep, which is 40%. Or material in pen, we can say the pen is retaining and 40%. So we divided the this particle. So we know that we can divide from 200 sheet. Upper level is coarse grain. It can be gravel and sand, and below the 200 sheet is it will know the fine grain. So fine grain will be silt and clay. And another portion is below above of number 4 sheep, which is gravel, and below the number 4 sheep, which is sand. So we have seen the material passing for number 4 SIP, which is 76%. So 76% we are drawing here. No, number 4 SIP is going to the 76%. On the other hand, we can see, if we take the all the portions is 100%, we can see the second line is all the portion is 100%. So if we deduct the 76% from the third line, 76%, would we divide the 100 in subtract the 14 we have already know the material is passing 200 ships. So 14 is here, this is the 14, as the material is passing 200 and it retaining pen. So we can say the 14, so we divide, subtract 100 minus 14, so we have found 76%. On the other hand, we can see the number 4 graph, which is 100 minus 76, and we can found the 24 percent. And the third graph we have drawn, as we know, the 100 is total, and subtracted 24 is above, and subtract 14 is below, which is the silt or pen. So we have found between number 4 SIP and number 200 SIP, it is written 62%. So this is the main drawing. We have to draw this line for our study, or if we don't draw this, then you can solve the problem. So coarse grain portion is 86. So how we'll get 86? We can see the third number line is 86, and gravel 24. How we'll get the 24? 24 is number 4 line, which is 100 minus 76. And sand we have found 62. How we'll get 100 minus 24 minus 14? So we'll get 62 material. So the gravel, we can percent of gravel minus coarse grain into gravel divided by coarse grain into 100. So gravel we know 24. Here is a gravel 24 at the above the number 4 SIP. And the coarse grain, we know the 86. Here is a coarse grain 86. So we know the 86 coarse grain is above the 200 SIP. So we have found 27.91%. In the same way, we can found the sand, which is sand 62. How we'll get the 62? 62 is below the number 4, between the number 4 SIP and 200 SIP, and divided by coarse grain in 86. So we have found 72.09. As the value is 72, so which is above the 50%. So above is 50%. So this is the sand. Okay, so we can say the example of giving this example. So we can say this particular sand. Okay, so let's see another example. Okay, so this gradation we have to must be memorized. So we are divided gradation, well graded and poorly graded. Poorly graded is divided over divided into, which is uniform graded and graded. We must be memorize this formula, some important formula for soil gradation. Okay, let's see how we'll memorize. Find pen. At first I have already shown here. This is the pen. This is 200 millisip and 4 millisip. So we'll always concern on pen, and also between 4 and number 4 SIP and 200 SIP, but not upper the 400 number 4 SIP. So we always concern the pen or below the 200 SIP. So let's start. When the pen is less than 5%, so we can say the soil will be gravel or sand. That's why we will say GW, which is gravel oil graded, or GP, which is gravel pore graded. Otherwise we will say sand oil graded or sand pore graded. So these four criteria will be must be free, must be categorized when the soil is below the 5%. Then will be gravel oil graded or gravel pore graded, or sand oil graded or sand pore graded. And the second time when we'll see this will be second, this time when will pen retain sorry okay, let's start. When will this is the okay, when will pen is retaining 12% to 50%, then we will say gravel silt or gravel clay, or silt sand silt or sand clay. So this we can must be memorize another thing. The sequence is gravel, sand, silt, clay. Gravel, sand, silt, clay. So when the soil is retaining pen between 12% to 50%, then we will say gravel silt or gravel clay, or sand silt or sand clay. Okay, when the this is the very important, because this in the real field and exam in the exam hall, the question is come from here, because when the pen is retaining 5% to 12%, then we can say gravel oil graded, gravel silt, gravel oil graded, gravel clay, or gravel pore graded, gravel silt, gravel pore graded, gravel clay. Otherwise we can say sand oil graded, sand silt, sand oil graded, sand clay, or sand pore graded, sand silt, or sand pore graded, sand clay. These four criteria are fulfilled this when pen or 200 here is the pen, here is a pen, or we can say the below the 200 sheet. When the pen is above 50% particle or finer, then we will apply this formula. How we will apply? This is the sand, this is the graph which is below the sand, and between this is the graph, and these are the plasticity index. When the plasticity index is above, then we can say clay. When the plasticity index is between this line and this line, we can say silt. When the and below the this line, horizontal line, then we can say salt. So the plasticity index 0.75 into liquid limit minus 20, and on the other hand plasticity index and another formula is liquid limit plus plastic limit. So let's see. Let's see the example. The example is given 60% material is smaller, or which is finer than 0.4 mm, and 70% material is coarser than 0.09 mm, and 10% material is in pen. So we already memorized these four. So we can say that 60% material we can denoted this 60, which is 0.4 mm, and another one is 70%, which is, if we deduct 100 minus 70, so we can say this 30. So the 30 is given 0.009 mm. And the last one we have shown here, the 10% is material is pen, so we can denote a 10%, which is D10, and retaining the sand particle is 0.075 mm. So now we can apply the formula, uniform the coefficient, which is Cu. We know the Cu equal to D60 minus D60 divided by D10. So we apply D60 divided by D10, and we have found 5.33. And in the same way we have applied the coefficient of curvature, which is Cc. The Cc formula will be D30 square divided by D60 divided by 10. So the value is 0.27. So CU we have found 5.33, which is below is 6, and CC 0.27 is not between 1 and 3. So this is poor graded selected. So the soil is poor graded. If Cu greater than 6 and 0.27, which is not between 1 and 3, so and pan 0.27, so poorly graded sand. If Cu 5.33 is less than 6 and CC 0.27 and not between 2 and 3, and pan is retained 8.5, so the sand will be sand poor graded sand clay or sand poor graded sand silk. Okay, so there pan is 10%. Okay, these are the another example. So we have to the perform of the necessary calculation and plot the grain size distribution. Here is the grain size distribution we have to perform or draw, and determine D10, D30 and D60 from the grain size distribution curve and the uniform coefficient of CC, and calculate the coefficient of curvature CC. So D10, D30 and D60 we have to understand at first what is the D10, D60 and D30. So this is the grain particle distribution side. So at first if we show the here coarse grain is 40%, so this is finer. So we can see we can call D60, which is coarse grain 40% is and the finer is 60%. So finer is 60%, this means D60. If the coarse grain is 70%, so finer will be 30%, which we call the D30. If the coarse grain is 90%, the finer will be 10% D30. So D60 means the finer particle. D30 means finer of the 30% is finer. D10 means the 10% of finer. So D10 I have written here again. The D10 particle size is corresponding to 10% finer. This is finer. 10% material is smaller or finer than the size of in the same way D30 is 30% finer and D60 is 60% finer. So it's all about the finer. Okay, so now we back to the example. So this is the US SIP number 4, 10, 12, 40, 60, 120 and pen, and the materials is retaining each SIP, which is 0, 21.6, 49.5, 102.6, 89.1, 95.6, 60.4 and 31.2. And now we can solve this problem. How we'll solve the use the SIP number is given here, the SIP number is taken here, and number of opening we have also written here in millimeter. Number 4 milli is 4.75, 10 milli is 2 millimeter, and 20 milli 0.85 millimeter. In the same way 20 number SIP is 0.075 mm. So mass of retaining here is given here 0 is 0.21. We are writing here 0.21, and in the same way, and sum of the all all retaining soil is 475 gram, and cumulative mass of retaining above each SIP, this is percentage retaining. We can show the 0 is here, and 0 plus 21, which is 21 plus 49.5, which is 71. I am zooming again and showing here. And 49 plus 72, which is found 173.5, and 102.6 plus 89.1 and found 26.6.8. In the same way we are adding 89.1 plus 95.6 So we will found this value, and finally if we um, um, if we if we divide by 10 in the 100 divided in the last digit, then we will found the FM, which is 4.17. These are not needed although. So on the other hand, we can see the 0, and we have found in left side is 21.6 into 100 divided by 475. How will calculate this? We know the wall materials, here is the wall materials is 47 is passing 21, so 21.6. So number 1 gram is passing 21 into 6 divided by 450. So 100 gram is passing 41 into 41.6 into 100 into 475. So I have written here this here 41 into 100 divided by 450 and found 4.7. In the same way 70 for 70.1 we have found here and 173.7 and 266.6. And we have found the finer. We know the at first is finer is 100, and 100 and the second one found 100 minus 4.7 is 95.2. In the same way 100 minus 50.8 found 84.2. In the same way 100 minus 38.8 and minus 38.8 and found 62.2. In the same way we have found 100 minus 93.07 and found 6.93. So all results are found. Now we'll draw this plot. So remember, this plot is drawn from left side, which is 0.06, 0.1, 0.3, 1, 3, 10. So the graph is log scale and graph from left side, and the vertical side is percentage is finer, which is 246, 8, 18 and 100. So at first we know the 30% D60. So the particle size is 60%. So we will draw this graph and going to the 60%, and 60% is intersect this line and found here. This will be D60, and we have found D60 0.41 approximately. We have found 0.41. Here is we have written here. In the same way we will calculate the 30%. Here is the 30%. We will call D30. So and intersect this line and found this here. So D30 is 1.11. So here is a 0.18. We have found 0.09. Sorry, D30 will be 0.18. Here is the D30 0.18. In the same way D10 is 10% particle is intersect here and found 0.09. So we are 3 value we have found from graph, which is D60 0.41. Here is a 0.41 and D30 0.185, 0.185, and the last one D10 is 0.09 found here. So putting this value for getting uniform coefficient C, we know that D30 by D10, and putting this value D60 from here, D60.4 and D10 is 0.09 and found 4.19, and coefficient of curvature CC D30 square divided by D60 divided by 10 and found 0.93. Okay. So another basic we have to memorize. I have already shown the plasticity index 0.73 liquid minus 20, and the graph is below silt and clay in here, and plasticity index liquid limit minus plasticity. when the liquid limit is greater than 50%, then we can say higher plasticity. Then liquid limit is lower than 50%, and then we can say lower plasticity. Okay. So let's see the example. So if pen is retaining 62, so pen is retaining 62, and liquid limit is for 40% and plastic limit is 31%. Then classify the soil by USGS. Okay, so we know the plasticity index, the formula 0.73, liquid limit plus liquid limit minus 20, and found putting this value and found 20.4. So the graph, we can see this graph is here. This is the 20.4. And plasticity index, another formula, liquid limit plus plasticity, plastic limit, and found 17, which is below the for 20.4. So 70 is below the 20.4. So this is the silt. How we will call silt? As we know already, found formula, or we have to memorize this formula, that this graph is plasticity limit is when the value is the plasticity below the when the value is above the plasticity index, then we can say the clay. When the value is plasticity is below the plasticity, then we can silt, we can say silt, which is this value. We have found the plasticity value is 20.4. This value is 20.4 here, and the plasticity index we have found 17%. So 17% is below the plasticity index. So we can say must be this is the silt. Okay. Another example we have shown here. If the pen is 62% and liquid limit is 30% and plastic limit is 31, then classify the soil. The plastic limit 0.7, plasticity index is 0.73, liquid limit minus 20, and found 31. So this is the 31 graph. And plasticity index, liquid limit plus plastic limit, and found 7%. 7% is below the 30%. So we will must be. So this is the silt. The silt. So lower plasticity. How we will get the lower plasticity? We have already shown how we will get the lower plasticity. Lower plasticity or higher plasticity depends on the plasticity limit. If the plasticity is greater than 50%, then higher plasticity. If the plastic limit is lower than 50%, so lower plasticity. So in this way, we have shown the liquid limit is below the 30%. 50%, which is given in 38, so we will get the lower plasticity. Okay, so we can see the another example, which is if the pen is 62% and liquid limit 68% and plastic limit is 50%, the classify the soil according to USGS. The plasticity index 0.73, and putting this formula again and found 35%, and liquid limit minus plastic limit, and found 80%. So 30% is here and below the 80%, so we will call silt. But we have shown the liquid limit is 68, so this is the higher plasticity. So silt, at first we select the silt, then we select the higher plasticity. So we can say the soil is silt and higher plasticity. This is our answer. Okay, so we can denoted the symbol M. M means the silt, and H is higher plasticity. Okay. Now we will go to another page. Here is the basic. We must be memorize the classification of soil, coarse or grain. How we will define coarse or grain. So depends on 50% soil passing or retaining by 200 sheep. If the sand is passing 50% by 200 sheep, so 50% is passing 200 sheep. So this is the final. We already said the final is silt and clay. This is the very important. And on the other hand, if the particle is retaining by 200 seep, then it will be coarse. Coarse means sand and gravel. When we will get the finer, then we have to define the plasticity, lower or higher. If we go to the coarser gravel or sand, then we have to define the gradation, oil graded or pore graded. Depends on the pan retaining. Okay, which is 5%, 5% to 12% and 12% to 50%, as we already shown this mathematics or example before. So now we will see the another example. Here, this is our last example, and we will not see one more example. This is our last example, and this in this example we will cover all the topics, all the calculation. Given data which CU given, coefficient of uniformity, and this CC, which is curvature 1.5, and liquid limit 35% and plastic limit 25%. In addition, the data is given. It is also found that 10% material is finer than 0.075. Calculate the size of the particle from which 60% materials is finer. Also identify the type of soil. And number B, in addition to the given data, it is also found that 60% material is finer than 0.075. Classify the soil according to the USGS system. So there are the two type of questions arise. So I will solve. So at first we will take in the CU 2.8, CC 1.5, liquid limit 35%, plastic limit 25%, D10 0.075 mm, which is 200 seep, and D60 we will calculate. So CU equal to D60 divided by D10, and found CU 2.8, and putting 2.8, and D60 will be unknown, and D10 we have given here D10 0.075, and found D60, which is 0.21 mm. Okay, as we can 60% material is passing to 2.1 millimeter. So we will go to the question here, which is given the 60% material is passing 0.075, which is 200 seep. So there is a 200 seep, we can know 0.075. So above the 200 or 0.075 mm seep, we can say coarse will be gravel and silt. And we have found D60, which is 0.21 mm. Here is a 0.21 mm. As 60% material passing, 60% material, so we can see the 16% material is passing is 0.1 mm. So here is a 2-1 opening, but 60% material not passing 0.075 mm. 60% material we have shown the passing 0.1 mm, but not passing 0.01. So or 60% material is retained 0.075, or we can say that the materials retaining in this portion between 0.075 and 0.1. So it is coarse grained soil, either stone or sand. Okay, as 60% material 0.75 also 0.21, so it is sand. So we can clearly say seen that the 60% material which is passing 0.21 but not passing 0.75, so we can say this is the sand. I will clarify. We already must be memorized this. The at first we will divide the 0.075 is a below the 0.075 it will be finer. Finer means silt and clay, and above the 0.075 which is coarser. Coarser means sand and clay, sand and gravel. the sand and gravel will be divided another portion which is 0.075. Above the which is divided 4.75. Above the 4.75 is gravel, and below the 4.75 is sand. So sand is situated here 4.75, between 4.75 and 0.75. So we have writing here 60% material is passing 0.75, also 0.21, so it is sand. So it is clearly sand. Finally, as we show the Cu, as you saw the Cu 2.8, which is less than 6, and Cc is 1.5, not which is between 1 and 3, so poorly graded. So it is poorly graded sand. So finally we can select the poorly graded sand, SP. We can say SP. This is our first answer. And now we'll go the second, which is D60. D60 means 0.075. Here is a 0.075. So second portion we can see the 60% material is finer than 0.075. That means the 60% is material passing 0.075. So here is we can see the 0.075, 60% material is passing. So this material is finer. So now we will select the finer is it clay or silt? It is silt or clay. So we will define what is the particle. Is it silt or clay? As the 60% material passing 0.075 is opening also 200 C, so it is fine grain soil, either silt or clay. Now we'll see define how it is silt or clay. As 10%, 10.9% is greater than, how we'll get the 10%? Okay, now we'll calculate the plasticity index for dividing silt or clay. How will divide silt and clay? As we know, the plasticity index is 0.75, liquid limits minus 20, so liquid limits is 35%. As here is given the liquid limits 35%. So 35 is found 10.95. Here is a 10.95. On the other hand, we know the plasticity index at the liquid limit minus plastic limit. So liquid limit is 35 and plastic limit is 10. So the 25. So the value is found is 10. So we can see this is the silt. Here is the clay. Here is the silt, and here is the sand. So the value is found below this line. So it is called silt. I will get. This is the formula. We have already shown the many times. Here the clay, silt, clay, silt, sand. So the value is between here. So it is called silt. Okay. So as the 60% material passing 0.75, which is 200, I have found that 10.95 is greater than 10. So this is silt. So the select is silt. As the liquid limit is 35%, which is below the 50%. So this is lower plasticity. So finally, at first we have select the silt. This is silt. And the liquid limit as the below the 5 and 50%, so this is the lower plasticity. And finally our answer will be silt and lower plasticity. First answer is poorly graded sand, and second answer is silt, lower plasticity. This is the important question, and I hope you can understand all my talk, and thank you for patience. If you have any question, then let me know, and write in comment box. I will try to answer your question. Thank you.